Welcome to the Dargslan series, 24 parts on running AI locally on Linux, and we're starting at the beginning. Before we touch a single config file or pull down a model, we need to answer two simple questions. What actually is a large language model, and why would you bother running one on your own machine in 2026? That's the whole job of part one. No setup, no code, just the why. So let's start with the first question. Underneath all the marketing, a large language model is just a function. You feed it some text, and it predicts what text should come next. Give it, "What is the first rule of Fight Club?" and it produces the line you'd expect. That's the entire core mechanic. Chatbots, agents, retrieval systems, everything we'll build over the next 23 parts is just clever scaffolding wrapped around this one simple loop. Before we go further, three words will keep coming up, so let's pin them down now. A token is the model's vocabulary unit, not quite a word, more like a fragment, roughly 100 tokens for every 75 English words. A parameter is one of the numbers stored inside the model. When you hear 7B, that's 7 billion of them, and more means better quality but heavier on RAM. And context is the window of tokens the model can actually see at once. 8,000 tokens is about 6,000 words of memory to work with. Get comfortable with these three, and most AI jargon stops being mysterious. With that vocabulary in hand, let's look at the fundamental split in how you actually use these models. Cloud AI, your ChatGPTs, Claudes, and Geminis, runs on someone else's GPU farm. You send your prompt over the internet, pay per token or by subscription, and get access to the largest, freshest models, but the provider sees everything you type. Local AI flips every one of those trade-offs. Tools like Llama, Llama.cpp, and LM Studio run on your hardware. Your data never leaves the machine, and once you've got the gear, it's free. The models are smaller, but as we'll see, surprisingly capable. And that last point, your data never leaves, is reason number one to go local, and in 2026, it's probably the reason. When you use cloud AI, your prompts travel to servers you don't own, and the provider is free to log them, analyze them, and feed them into the next generation of models. Run the model locally, and that whole chain collapses. Your text goes from your keyboard to a process on your own machine and back. Nothing leaves. That matters enormously the moment you're working with medical notes, legal documents, proprietary source code, internal company data, or a personal journal. Reason two is cost, and the shape of the cost is what really matters. With cloud AI, you're renting access by the token every month, forever. $20 for a ChatGPT subscription, more if you're hitting the API, and heavy users can easily push past $200 a month. Local AI flips that into a one-time purchase, maybe nothing if your existing laptop is good enough, or $300 to $600 for a mid-range GPU, plus a few dollars of electricity. After that, your monthly bill is essentially flat and predictable. Reasons 3 and 4 are about responsiveness. Cloud APIs spend 200 to 500 milliseconds just getting your request to a data center before the first token appears. Local models start streaming in tens of milliseconds, which transforms how interactive the experience feels. And because there's no network in the loop, your AI works on a plane in a cabin on flaky Wi-Fi. No rate limits when you want to chew through 10,000 documents, no surprise API price hikes, no deprecated models. The one you download today still runs identically 5 years from now. But honesty matters, so let's flip the coin. A 7B model running on your laptop is genuinely useful, but it won't out-reason GPT-4 on the hard stuff. Cloud costs nothing up front. Local needs a decent CPU or ideally a GPU. Cloud silently upgrades itself while you decide when and what to update locally. More control, more responsibility. And setup is real work. 5 minutes for your first chat, but a full RAG stack with a web interface is a weekend project. Knowing when cloud is the right answer is part of the skill. So here's a practical decision guide. Anything touching private documents, daily meeting notes, or boilerplate coding, that's local territory because the volume is high, the privacy matters, and you don't want to pay per token for routine work. Quick public questions? Either works. But for the hardest reasoning, the deepest research or cutting-edge image generation, the frontier cloud models still have the edge. Most serious users end up running both, and that's the honest answer. So which models can you actually run? At the low end, something like Llama 3.23b or Phi 3.5. Mini fits in 2 GB and runs on any laptop, genuinely useful for chat and summaries. The sweet spot for most people is the 7 to 8 billion parameter range, like Llama 3.18b or Mistral 7b, which need about 8 gigs of VRAM or will run on CPU if you're patient. Step up to QN 2.514b for serious coding work, and only chase the 70B models if you have multiple GPUs or a maxed-out Mac Studio sitting around. To make this concrete, here's a sneak peek at where we're headed by Part 5. 2 commands, one to install Llama, one to pull and run a small model. That's the entire path from nothing to chatting with a local LLM. About 5 minutes, no API keys, no accounts, no cloud. We'll take our time getting there properly, but I want you to see how short the runway actually is. Before we wrap up Part 1, let's clear out 3 myths that keep people from even trying. First, that local AI is a toy. It isn't. An 8 billion parameter Llama handles roughly 80% of everyday tasks just fine. Second, that you need a $3,000 GPU. You don't. Smaller models like Phi 3.5 run happily on a modest laptop. And third, that this is researcher territory. Also no. If you're comfortable in a terminal, you already have the only real prerequisite. With the myths out of the way, here's a quick preview of the toolkit we'll be building up over the series. Llama and llama.cpp are the runtimes that actually execute models. OpenWebUI gives us a chat interface, LangChain handles orchestration, and Chroma or Qdrant store embeddings for retrieval. LiteLLM acts as an API proxy, Whisper brings in speech, and N8N ties workflows together. Don't memorize any of this. Each one gets its own episode when we need it. Before we wrap up Part 1, let's pull the threads together. An LLM at its core is just text in, text out, a next token predictor with a lot of scaffolding around it. Going local means your hardware runs the model and your data stays put, which buys you privacy, lower cost, lower latency, and offline use. The trade-offs are real: smaller models, a hardware bar to clear, updates you manage yourself. But in 2026, open models, tooling, and consumer hardware have finally lined up. This is the right moment to start. Before we close out, here's a cheat sheet worth bookmarking. You've got the 8 terms that'll carry you through the rest of the series: LLM, parameter, prompt, quantization, token, context, inference, and RAG. Don't worry about memorizing them now. Just know this page exists. Whenever a term trips you up in a later part, come back here and the definition will be waiting. And that wraps Part 1. 1 down, 23 to go. Next time, we'll map out the local AI landscape itself, the major model families, the runtimes that actually execute them, and the tools worth knowing in 2026. By the end of Part 2, when you type Llama list, you'll know exactly what you're looking at and why. See you there.